force garbage collection on Unity. But if you don't do it frequently enough, it will decide to do it on its own. And it's going to decide to do it in a time you don't want. So maybe it's not when you're loading a level where no one will notice a hiccup of 1/10 of a second. It might do it in the middle of a big attack animation where that hiccup is noticeable. Or your frame rate takes a dump because it decides to spend, 100 milliseconds doing a garbage collection. This is why I always try to do that stuff myself. I'm not going to leave it to Unity or Unreal to do that for me. Also, I mentioned optimization. I may think of places to optimize while I'm doing this, but you do optimization afterwards. One thing I mentioned was, let's say there is something that in the attack packet that's kind of expensive to calculate. Maybe it's what the target's armor is. And you need to look it up because the sound system looks it up to decide what sound to play, because a sword on leather sounds different than a sword on plate mail. Maybe it's the combat resolution itself that says I need to know what the damage resistance was on the victim's armor. Maybe of the 15 or so events that this packet flows through, 10 of them are looking up the victim's armor. You may, during optimization phase, go, that's expensive. I will look it up once in combat start and store it. But maybe of those 15 events, only 3 or 4 do a lookup, and it's not that expensive. Just look it up. That's why you save optimizations till later, and you decide to do just the ones you need. Because if you over-optimize, you're wasting time that you could have spent fixing bugs that are important, but your optimizations may do nothing. They don't help the frame rate, they don't reduce memory, they did nothing. So, I just want to throw that in there because that was an example of how I do this. Anyway, so to summarize, the way I've always loved doing combat is there's a combat packet that contains all the data about a single attack of an attacker on one or more targets. That gets created by a combat manager who handles it independently of any of those attackers or targets. It can be referenced by all the events, and the event handlers handle all the stages that attack goes through. Anyway, it took me years to figure that out. I used to do it with the much more non-event based code, the very deterministic coding. That was a mistake. This is the way I do it now. So that was a bit of a technical discussion. Hope people like it. Hope people like listening to it. I can do more of those. Let me know.
Hi everyone, it's me, Tim. Today I want to talk about common sources of programming frustration. This is probably going to be a long video. It's also me talking to programmers, so while it may be of interest to non-game development programmers, it's probably only academically interesting to any of the game development people who aren't programmers. Although there are some things in here I think some production people should look at. Just be aware of. Because I got a couple production things to say at the end of the video. But let me also say that this is not going to be the same video as the one I did on challenges facing programmers in game development. That's more of a team-related thing about, the challenges of working with non-programmers. This is more of things that will happen when you're programming that will frustrate you, aggravate you, throw you into a rage, and pretty much sometimes put a roadblock in on development. I'm going to talk about what they are, the different ones that have happened, and maybe give you some ideas of how you can ameliorate these. I don't think I can solve it, but I think I can help ameliorate it. So let's talk about a few things. First, let's talk about when you're using other people's source code. This could be a game engine. This could be a sound library. This could be the standard template library, STL. Eventually, you're going to run into a method that doesn't work. I'm not talking about a bugged method. I'm talking about something that is entirely unimplemented. And yet, in their documentation, it's implied that it's working. Now, I know this has happened with some of the modern game engines, and I'm sure you have stories about it, but this is not new. This happened back on Arcanum. We wanted to do some text processing in DirectX, and Arcanum was 2D. The text processing functions existed. They worked in 3D, Many of the pages implied they worked in 2D, but then I found one that said, this is not implemented yet. It will be supported in a later revision of DirectX. I think it was aliasing text. I don't remember. I mean, this is 20 years ago, and my note wasn't clear on this. Let me just tell you something. We worked on Arcanum for 3 years, and that feature never got implemented in 2D DirectX. I finally got a hold of someone there who said it wasn't being prioritized because everybody's going 3D. So this is something we waited on for years that function never got working. So we eventually just did it ourselves. Or I think we used drop shadows, so it still looked good against all the different backgrounds. So you have to be aware of that. You will sometimes use third-party software, and some of the methods they provide that they expose in their APIs do not work. I'm not talking they're bugged. I mean, they literally are unimplemented. So now let's talk about bugs. Not just your own, but also in third party. I've already mentioned in the Fallout 2 video, by the way, I will reference all these videos below. In the Why I Left Fallout 2, I talked about a memory overwrite, which was entirely caused by, the internal programming team, and how we spent 2 weeks looking for that. 2 very frustrating weeks. So I'm not going to repeat that here. What I am going to tell you about is another memory bug that we had early on. I think this happened about a year into development. No, it had to be more than a year, because Chris Jones helped fix it. So that would be a year and a half, maybe a year and a half, not quite 2 years into it. It was this. The compiler we're using was called Watcom, and we were using it because it had this really cool flat mode that let you access more than 64K of memory at once, which, me coming from Unix background, I thought was an archaic limitation on Windows, that I could only grab 64K blocks of memory. So anyway, Watcom lets you do a flat mode. Great. Full 32-bit pointers. Love it. We ran into a problem. We started noticing memory overwrites. And what was weird about them was we traced it into functions that were writing within the boundaries we set. So let's say we had a block of memory 1,000 bytes long. We'd write 900 bytes into it, and then we get a memory overwrite in another block of memory in another piece of code. We finally traced it, and it was a pain to do this. We noticed that the blocks that were complaining about being overwritten had all been reallocated. In memory, you can malloc, which is create a block, free, which is release it, and reallocate. Reallocate says, I want to take that block of memory I have and make it a little bit longer. And if it can just add to the end, that's great. Otherwise, it has to find a new, bigger block and copy your old data to the beginning of it. So then you have the extra memory at the end. We'd reallocate some blocks in Fallout, and these were the ones that were reporting the errors. So I sent an email to the Watcom support email, and they wrote back, no, it's almost certainly a bug. Actually, no, I don't even think they said almost. They said, it's got to be a bug in your code. We know nothing about what you're talking about. This kind of made me mad because I thought it was pretty obvious from our code what the problem is. So I wrote a 5-line program. The first 2 lines looped over and malloced 1,000 blocks. The next 3 lines looped through those malloc blocks, would reallocate them to bigger sizes, and then look to see if the reallocate block conflicted with any of the other 999 already created blocks. And it just kept looping and looping forever until it finally saw one of them conflict, and then it printed an error message and stopped. Let me tell you something. You could run this program and it would never run for more than 20 seconds before it would stop and go, this reallocate block includes part of a memory that was malloced for an earlier block of memory. I sent this back to support and I said, here's 5 lines of code. Either tell me where my bug is or admit that you have a bug in reallocate. 48 hours later, to their credit, they said, we have a bug in reallocate. It'll be fixed in the next revision. Now, 2 things I just want to make clear here. They probably get thousands of support messages where the error is on the programmer using the compiler. So they probably just thought I was another one of those programmers. So I get why I got the initial feedback. I was just a little, this is wasting our time. But also, I'm going to talk later, Chris Jones went in and saved the day by we ended up writing our own memory allocation routines. And I'll talk about that at the end. It's part of how you can solve some of these frustrations. So the next thing I want to talk about is user interface. I find user interface code to be some of the most painful and frustrating code I've ever written throughout my career. It was a pain in the 80s, and I find it to be a pain in the 2020s. It's hard to exactly explain why, other than it seems to be an enormous, frustrating time sink with endless causes of bugs. Not just because of what I've already mentioned, which is sometimes there will be a method that isn't implemented or a method that doesn't work the way exactly they describe it will work, but for a third reason, which is among UI APIs, often if you want to do it exactly the way they describe it, it's easy. If you need a tiny change, like I need that button to be transparent or I need that button to be non-rectangular, oh my God, it is like extracting teeth. It becomes the most painful change. And you can have an artist who's just like, but I thought we agreed a year ago that we would have round buttons. And you're like, It's something that changes the schedule to, I could have had this done in a day, and now it's going to take me weeks. Take note, production people. Is this something you could have predicted? We'll talk about that later. Now let's talk about changes to design, or just changes in general. Sometimes the designers will write a design for something, system design, a UI design, narrative design, something. You'll code it up, and then they change their mind. They haven't even run what you've done. In between when you coded it and it was being tested, they went, oh, we've had to change our mind. Now, that's really bad and annoying. It's like, couldn't you have thought of this before? But let me tell you a second thing that happens too, which is they write a design, everybody looks at it and goes, that's good. You then code it, then it's being tested, and QA discovers issues with it. These aren't bugs. The code is a flawless recreation of the design. The design itself has a bug embedded in it. So now the design has to change. This isn't so bad. You shouldn't get so upset about it. It's not uncommon, but it's not super common. It happens is basically what I'm saying. So you again have to change your code. I'm sure a lot of programmers know where I'm getting at this, why this is frustrating. Lots of changes to code tends to lead to what's called spaghetti code. When you wrote the code the first time, it was really well designed. But then, because the design changed, for better or for worse, you had to go in and change things. Then you had to go and change things again. And then there were bugs, and you had to go and change things again. Now the code looks pretty bad. And at this point, you may have a lead who's getting mad at you, like, why did you write such horrible code? And you're like, I didn't. My code was a flawless gem, and then things changed. Now, you could say, well, when you rewrite it, you should have made it flawless. Like, I'm often given like a day to fix this bug. I didn't have time to rewrite the entire section of code. So that will lead to frustrations for programmers, especially between programmers and productions. So now let me say why this is something I wanted production people to be aware of. All those sources I talked about, design changes, bugs in your code, bugs in third-party code unimplemented but documented elements, user interface, just user interface across the board. These are things that lead to slowdowns in programming and then later on lead to crunch. And I'm of firm belief that there is no magic production wand that can foresee and fix all these things. I've already done 2 videos on crunch. Please watch them both if you think I either don't know what I'm talking about or can't come up with counterexamples, because I can. So what I'm saying is, to production people and then to all the non-production people going, it's management's fault. No buffers of time, no fallback designs, nothing of this can account for all of these things that will happen. And even if you accounted for them, some of them are just unavoidable. They will happen. And you're thinking, well, we'll make buffers. You probably can't, unless you make such a big buffer that you run into the other problem I'm talking about, where it's so cautious that you come up with a design and they say it will take 2 months to do this. You're like, you sure it won't take 2 days? 2 months. Because you're trying to account for all those things that might happen and often won't. Like the Watcom error. When Watcom originally sent back, I was like, maybe they're right. Maybe it's our code. There are 2 other games here that use Whatcom and they're not running into this problem. Well, it was because it was in realloc. And they were just malloching and freeing. They were grabbing blocks, using them, and then letting them go. We reallocked the block. That's where the error was. So that's not possible to foresee. Nobody could have gone, hey, I'm going to put up some buffer of time here in case your compiler is broken. And by the way, that's not as far-fetched as it sounds. I've often seen compilers broken on the optimization flags, where you have a perfectly running piece of code, but it's kind of slow. You turn on the compiler optimization, and now it runs really fast, and it's broken. A whole bunch of different things that can happen there. I'm basically saying production can't account for all this. They literally cannot. So what is my solution? I have 3 different suggestions on what you can do when you run into these frustrating programming situations. These are all for programmers to deal with. The first thing you can do is switch to something else for a while. Just jump to another piece of code, go home, go ride your bike, go do something else for a while. Just don't have eyes on this piece of code. You'll be surprised at how frequently you come back in a day or two, look at the code and immediately go, oh, there's the problem. This used to happen all the time when I was in engineering school, and some of my non-computer science engineering schoolmates would have a programming problem and they couldn't see it. It was like, it's a very simple Pascal program. And they're like, I don't understand. And then I'd look at it and go, oh, you're missing a semicolon at the end, because you had to have a semicolon at the end of every Pascal line. And they're like, ugh. And the reason the compiler didn't see it is those compilers were somewhat primitive. And with the lack of a semicolon meant they went to the next line and possibly the next few lines. And the next line happened to be a comment. And then 2 lines down, he finally had a semicolon. And so it grouped all those lines together, tried to process it into something, and then came up with some obscure, like, I don't know a method to call for this. And it's like, no, it's just you're missing a semicolon. It's hard to see. Sometimes, just going away for a while. But it brings in my other point, which is sometimes bringing in another pair of eyes can massively help you out. I'm not a big fan of pair programming, which is 2 programmers working on a piece of code to produce it. But I'm a huge fan of pair debugging, which is if you get stuck trying to figure out what the bug is in your code, sometimes bringing in another programmer and saying, watch what happens when I step through this. Sometimes that other programmer will go, oh, something just stomped on your memory. Oh, this isn't the method you want to call because it doesn't check for capitalization in strings or something like that. Sometimes they just immediately see it. So if switching to something else or getting another programmer to look at it with you isn't something you can do, then sometimes you just have to rewrite it. And that's the third solution. Just rewrite the thing. But when you rewrite it, don't rewrite it the same way. Use a different algorithm. Use a different set of data structures. When we ran into that realloc problem from Whatcom and we did not know how long it was going to take them to get back to us, Chris Jones, the other lead programmer on Fallout, pointed out that we were also having fragmentation issues in DOS, where we were having, between all of our mallocs and frees and reallocs, we were having memory all over the place. And he suggested rewriting our memory allocation system to do 2 things. 1, we malloced 1 giant block when the game started, and that's all we used. And all the mallocs, reallocs, and frees happened within that block, and they all happened through handles instead of pointers. A handle is a pointer that you have to say when you go to use it, I'm locking you, and then you get a pointer you can use. And then when you're done, you say, I'm unlocking you. The cool thing about that is at any point you can say, try to defragment memory, and any pointer that isn't locked, any block that isn't locked, can be moved around. And you can try to coalesce all your memory into one spot. And even if you have holes in memory, you can coalesce them into a big block that maybe can be used to give you memory. Chris did that even before I think Whatcom fixed realloc. Not only did that avoid the realloc problem we were having with our compiler, but it saved the DOS version of Fallout, which was having massive fragmentation issues. I mentioned that, I think, in my Fallout timeline video. So here's what I want you to get out of this. If you're a programmer, whether you're in game development or not, you're going to run into a lot of these frustrating things. They just happen. I also think they're unavoidable. They're unforeseeable sometimes. Except maybe, I've got UI, I'm going to quadruple my time estimate, because UI always is a time sink. But for a lot of the other ones, you could double it or whatever, and you're still going to run into things you absolutely did not foresee. The only solutions I have is jump to something else, bring someone else in to help you debug it, or just rewrite it from scratch in a whole new way. These I've found, sometimes I could rewrite it faster than it would take me to debug it. So I'm hoping these are things that can help you, and also for other people, make you understand why sometimes crunch happens, not because you have a bad team, but unforeseeable things can happen. It's game development. It's half art. It's not all science. So I hope this helps you, programmers and production people. Hi everyone, it's me, Tim. Today I want to talk about error handling. Specifically, I want to answer a question from Mudhole Creation, who asks, I'd love to hear how you versus the industry do error handling. Do you check parameters before you send them, or do you check them in the function they're sent to? Do you not use things like raw pointers so you don't have to do checks? Using print or trace functions? What about using asserts, exceptions, try catches? Also, what are your thoughts on rules like not using raw pointers, globals, or reinventing the wheel? Okay, Mudhole. These are good questions. There's a whole bunch of good questions. The very first thing you should do is probably watch the video I recently posted. I think it was yesterday. I'm losing track when I don't do these every day. On frustrations in game programming. I'll link it below, because that covers a number of things that tend to happen to programmers that make them go, "Urgh," but not specifically error handling. I'm lumping error handling in because when I get to the end, you'll see that there were some issues with error handling I never found a solution to, or I should say I found multiple solutions to, but I could never get the programming team to agree on which one to use. They were pretty evenly split. So let's talk about a lot of things you asked. First of all, parameter checking. Yes, I do those. I usually do those inside of the function that is called the receiving function. Why? Well, it's the receiving function that cares about those parameters the most. There are some calling functions that they received a parameter only to pass it on to you. They didn't create the parameter. They don't check it because they don't use it. They just send it right on to you because you're going to give them a value they do care about. Also, that means instead of lots of checks all throughout the code, everywhere maybe a object pointer is created or a value is created, and rather than check those in all those places, I'll just place it in one place, the function that's actually caring about it, because you can always add a breakpoint and then look up the call stack to see where that value came from, who was responsible for creating it, why it was wrong. So I usually try to put as few checks in by putting them in bottleneck locations. When I do those checks, I use asserts. I've used exception handling. I've used try and catch. I've also sometimes just used if-thens. Like if this pointer is null, then print, hey, there's a problem here. You shouldn't have done this. Because I can wrap that whole thing around a pragma that gets removed in the release mode. Which, let me tell you two things. First of all, pragmas are great for C++. You can use whatever preprocessor directive your language supports. Just as long as the idea is, let's get rid of this in release code, because by the time you release the game, it's too late to do anything. If someone gets past a null pointer for an object that has to not be null, there's very little you can do at that point. Now, this is one of the several places people have disagreed. Some people are like, yeah, but if it crashes. And I'm like, well, you'd like to think the code won't crash because of it, but you certainly aren't going to throw in a message or anything about it. And frequently, even if you don't crash, you can't continue. Let's say someone tells you to load a game and you call the function, and one of the first things it does is, this is an invalid file handle. What is it supposed to do? It can't load anything. It's not like you can continue. In that case, yeah, print something and be done with it. But in a lot of cases, you're checking things for being out of bounds or whatever, and you can throw that away in release because it slows you down in release. Similarly, anything that prints a message out for a game developer or does some kind of trace, a call stack, emit a call stack trace, or put something out in the console, things that basically aren't intended to be user facing, I wrap all those up in pragmas as well, and they get thrown away in release. All they do is if they stick around, all they're going to do is do checks that the end user can't do anything about and slow down your release code. So I tend to do things like that. Global variables. I frequently see in academia, people are like, you shouldn't use global variables. You're a bad person if you do. These are the same people who go, you should never have a singleton class. And bafflingly, I wonder if any of them have really written code that was put into production. And here's why. Sometimes you do need a global. Sometimes you do need singleton classes. There are so many games I've written where you need a class that handles save games, or a class that gives you like creature objects or prop objects. It generates them. The class generates and manages those class of objects, but you don't need a multiple versions of that management class. So singleton classes exist, global variables exist. However, sometimes instead of globals, I like to use accessor functions. So the variable isn't exposed. You call a get and set function inside it. C# people know what I'm talking about. The reason I do this is if you ever want to put breakpoints on the use of those variables, it's a little slower to use get and set. So there are times where for speed reasons, you expose a global because you're like, I can't slow down in this loop to call the overhead of a method. But sometimes you want to use a get and set so you can easily put a breakpoint on, hey, who's setting this variable to null, or who's setting this to 0, or who's setting this variable to out of range. You can put a breakpoint on the set function and find out, rather than find everywhere in your code that global is manipulated and set and put breakpoints there. Again, it's the try to funnel it. Now, a lot of modern compilers say you can put a breakpoint on something and say, show me when the memory at this location changes, and that's a perfectly fine way of doing it. Just know that it will slow down when you run the game. So if you're trying to do that in 10 or 15 variables, it's going to slow down the run. Maybe it's acceptable. Maybe it slows down so much like, gee, if I just had a get and set function, it'd be so much easier. Or make a get and set function for it and put it all in there, and then make those inline methods. A lot of compilers will do that for you when you optimize. If you have a one-line method, it will go ahead and inline it for you. Great. Understand what your optimization flags are doing, though, before you use them. Raw pointers. Again, I'm going to sound like a cuckoo clock here. Sometimes you need raw pointers for speed. You just need them. However, like I mentioned in my frustration video, sometimes you want to use handles instead. A handle is basically a pointer that the handle itself can't be accessed. You instead say unlock this handle and you're returned a pointer, and then you can use the pointer and then you lock it again when you're done. What's great about handles is not only, again, does it let you put a breakpoint in one location to see who is changing this pointer or where's this pointer being used, because you can see you can see when it's unlocked. You can put a breakpoint there going, if I ever unlock a handle and return this pointer, break. But it does, and also it has the side effect of if you want to ever get memory moved around or defragmented, you know it's safe to move a block of memory. If no current handle is unlocked that points to that block, you can move that block anywhere you want. And then the next time it gets unlocked, it'll point to the new block. The downside is we'll open you up to bugs where there will be a code path where the lock gets called, but the unlock never does. Maybe it gets locked at the beginning of a function and unlocked at the end, but then there's an early out on that function, and you're like, oops, it didn't unlock that. And then you end up with a pointer that's locked down and a memory block that can't be moved for no good reason. So you got to watch that. So I probably have the same answer for reinventing the wheel. It is very nice to use libraries like the standard 10-bit library for vectors and maps and hashes and lists and things you just don't want to constantly rewrite every single time you make your game. And it's the same thing with game engines. It's nice to use a game engine. You're like, oh, I don't have to write another renderer. I don't have to write another, pathing system. That's nice. But just keep in mind, you don't have any control over them. It's nice to use them. It will speed you up. But some of them don't even provide you source. So if you run into a bug, you're often
you often will lose time going, is this a bug on my end? Or am I using it wrong? Or is it a bug on their end? I'm doing everything right and it's happening to them. If you have the source, at least you can dig into theirs, but you will spend a lot of time trying to find out where that bug is happening and how you're going to fix it. So all I can tell you is if you're going to use something in STL, or you're going to use a game engine, or you're going to use any third-party library, whether it's sound or cinematic movie playing or whatever, you have to balance the time it would take you to roll your own versus the time you'll save if you use theirs, but then have to try to figure out where bugs are. Are they in your code or their code? This is something the programming lead and the seniors will have to figure out because it's unique by game. We had a lot of arguments on one of the games I made about whether to use the standard template library. And the reason was that particular STL library, I shouldn't say library because that's what the L is, that particular STL did not come with code. And one of the principal programmers was worried about efficiency and bugs. And because we couldn't see the code, we didn't know how things were implemented. So we literally had no control over that. But he did some measurements and he found that some of the implementations for some basic data structures were horrifically inefficient, especially the way we were going to use them. So you might want to check your standard template library before you just start using it willy-nilly. Similarly, there was one other area where we could never have error handling, where I could never get a team of programmers to agree on what to do, and that is, what do you do when you're error handling and you find a really serious error? Like if you didn't check this, it would either crash or really prevent you from going on, or it would cause such a serious issue that something in the game would just not look right anymore, or would not function right. Like a creature would not be spawned, or wouldn't be able to move, or wouldn't be able to attack. Something serious. Now, there were two groups of programmers for this. Some say, print a message and halt. The game cannot continue. Anyone using this version is going to stop, see an error message come out going, hey, this serious error just happened, go find a programmer. Or do you print, hey, I was supposed to spawn a creature here and I couldn't, just so you know. Or, hey, I just spawned this creature, but he can't move, just so you know. And go find a programmer. Sometimes you can even write, when you're writing it, you know who's responsible for if this error ever happens, that means Bob gave me a bad object pointer, go see Bob. Now, I had so many programming meetings where we would discuss whether to print and halt or print and continue. And there were good arguments on both sides. The halt people said, hey, it makes it very obvious that this bug has happened. It is a serious bug. It will not only get it fixed, but if you continue running, it will lead to a lot of errors being thrown into the Jira bug database that don't really exist. People will say, hey, the quest took me to this cave, but it wasn't there. Or, hey, the quest took me to this cave, but the monster wouldn't fight me. Yes, because you just saw an error message about it. But they don't care. They write up the bug anyway. And maybe they should. They saw a bug. They'll write it up. They can even reference that error. But then the problem is you fix that error and you have to go in and remove all those. Now the flip side is if you want to continue, let the print that error message continue. You get those bugs, but it lets other people do work. If somebody's like, hey, I was walking by this cave, I didn't even go in it, but because something was supposed to be outside the cave holding a spear and he didn't spawn, my game halted. So I can't even walk down the road to the quest I wanted to do because I get too close to this cave. It comes into my area of interest, however you define where you spawn things in around the player, and the game halts. So great, I can't test anything because of this stupid bug. Wow. I would say this discussion, this split of my programming group of whether to print a message and continue or print a message and halt when an error occurred, was probably up there with using standard template library as completely divided the team in two. For the STL, what we finally ended up doing was we used one that we had the source code for, and we looked at it and we warned some people about which ones were inefficient, which data structures and methods were available that were inefficient under certain circumstances, and we said, now that we've told you, you're responsible for it, for knowing that. for the print a message, halt and continue, what we did was early on, we printed and halted to try to get all those errors fixed. Later, we switched to print and continue, and we let the team know, okay, from now on, you're going to see some error messages. Once you see that error message happen, anything having to do with that creature or object or whatever it says in that message is not valid because it was not created correctly. It's not being used correctly, whatever the error message is. So we have to handle that error, but errors that are child errors from that, we're not going to pay attention. Thanks, Windows. And I thought that was a nice balance between the two groups, and they'd both be happy. Instead, I made them both unhappy. They were like, the ones that wanted it to halt were like, we're not halting anymore. And the ones that wanted to continue were like, hey, we should have continued from the beginning. So you will never make everybody happy, but those are the error handling techniques that I used in a majority of my games. And I think it helps. So I hope this answered your question. Mudhole creation. Hi everyone, it's me, Tim. Today I want to talk about time estimation. I've received a lot of requests over the last year for people asking for a good method to estimate tasks, because this is a frequent contentious point between people and either the people they manage or their managers, where time estimates are just off and then upset situations happen. I'm going to talk about what I consider to be a good way of making estimates and problems of over and underestimating. Now, a lot of people have asked. The most recent request was from Aegon Targaryen 1390, who asked, can you please do a video on time estimations and planning, and how to handle situations where the boss says it needs to be done in X days and you say it will take 3X days? Okay. One reason I've put off answering this question for a long time is it's very, very complicated. I remember when I first started in engineering school, this was in the 80s, a long time ago. In my first software engineering class, they talked about time to estimate writing code. And this had been something that had been a problem for decades already. IBM used to have issues with estimating programming tasks. And back then, there wasn't a whole lot of research into this, and also there wasn't a whole lot of history of programming. And languages were being developed, hardware was being developed, everything was in a state of flux. The only thing I really remember from that class is there was a model called Kokomo, which the input was how many lines of code had to be written, and the output was an estimate in man months, which right then should tell you a lot of what era it was. But what was interesting, even then, a lot of people, including me, had questions to the professor like, wait a minute, it only took number of lines of code? How did you estimate that? How did you come up with the estimate of lines of code? It doesn't take into account the type of code being written? Because as I can tell you right now, it takes me a lot longer to write 100 lines of UI code than 100 lines of gameplay system mechanic code. What about the experience of the programmer? Are you telling me a junior programmer writes 100 lines in the same amount of time as a senior programmer? Or maybe if they write the same amount of code, are you telling me there are just as many bugs in both and they're both equally efficient? There are a lot of problems with this. So I just want to remind everybody, this is a very complicated question. And it's different for programming and art and design and sound and literally any task you're going to do. I'm going to approach it a little more from the programming side because that's what I have the most experience doing. Let me also point out that this question is highly, highly, highly correlated with crunch, because like crunch, people tend to put the entire onus of the problem on one group, saying either the estimator is horrible or the manager is horrible for even asking for an estimate. And we're talking about that. So And of course, if you watched my channel for even just a week, you know that I'm going to give pros and cons and think that issues exist on both sides of that fence. I don't think you can point the finger at anyone and go 100% of the blame is on this role. So let me jump to early in my career. When I was first starting out, so this is me talking to all you junior programmers out there. I was usually given an estimate. So somebody would tell me, usually a senior programmer or somebody who was responsible for the project and the code, would give me an estimate and go, hey, I need you to do this. Here's how it works. I think it should take you a week. What I learned as a junior programmer was to ask questions. The first thing I'd ask is, why is the estimate a week? Can you tell me why you think it's a week? Normally they'd say, well, I've done this before. It took me a week. And I would frequently say, could I get a breakdown by day? And the advantage for that is if they break it down by day, it not only is broken down into much more constructive, understandable tasks, but you also know immediately if you're going off estimation. If at the end of the first day, you haven't finished the first day's tasks, you're probably not going to finish this in a week. Big tasks that I would say, if you're given a task that's a week, or even I've been given tasks before that are a month or 3 months, try to get those broken down into daily and sometimes even hourly. Sometimes things can be broken down into hourly. Like, here's something, shouldn't take you more than 2 hours. And that way, you know, if it took you all day to do that, something's wrong. It could be something's wrong with you. You didn't understand the task. You're just not very experienced, or the language doesn't have support calls that you're used to. You didn't know these library functions existed. Maybe it's on the manager. Maybe they were mistaking it. Maybe they were thinking of another task. So you try to figure that out. The nice thing about this, about breaking it down into smaller tasks, like I mentioned, is if things go off, and I mentioned going, you're taking too much time, but even if you take too little time, this is something you get to know soon and before a lot of time is spent. And yes, it's good to know. If somebody tells you this should take all day and you get it done in an hour, you need to communicate that because something happened here. Either they misestimated the task, or maybe you didn't do the right thing. Maybe they thought you were going to write the final function and have a lot more support and a lot more error checking and have it be efficient, and you just did the most basic task ever, and it's really slow and it doesn't check any of its parameters for errors. So communication is a huge thing. Let me give you an example of one of the very first things I did. It was in the second game I ever made, Bard's Tale Construction Set. I was given that, and I was told it would take 14 weeks to do the entire thing. Now, this is only the second game I'd ever done. And so even though I was the, quote, lead programmer, I still felt very inexperienced. I'd done one game before, and it was a bridge card game. So I tried to ask questions about, hey, why do you think it would only take 14 weeks? And one of the responses I was given was, well, most of the effort is going to be in combat, and combat you can pull out of one of the previous games because they're effectively a black box. Let me tell you what I discovered. 2 things wrong with what I was told. One, it wasn't a lot of time spent in combat. A big chunk of the time was spent in, you guessed it, UI. And as a subset of that, we had animating creatures in the UI. And I didn't know how to do that. I barely knew how the graphics mode worked. Putting delta compressed animation frames and rendering them at a particular frame rate was outside my skill set. Also, the first thing I did when I got home from that meeting, because I was a contractor, I was working at home, I dove into combat, and I discovered it was not a black box. The combat code was filled with things like, if monster equals dragon, then. Actually, what it said was, if monster type equals 52, and I had to go figure out what 52 meant. They didn't even bother using enums. It was a little bit of a nightmare code. I talk about this in the Bard's Tale Construction Set video I have. Anyway, so I was back a day or 2 later going, this is not what you said it was. And luckily, because I could back it up, I go, you said it was a black box? Look at this code. Look at this code. Look at this function. This is not a black box. And also I pointed out some things like, you want some things done that are outside my skill set. They did get an extra programmer put in. Phil Britt came on board to handle a lot of that animation stuff. Some of the estimates were changed. So communication. Now, later in your career, when you're a more experienced programmer, let's say you're a senior programmer, you're not a lead yet, you're a senior programmer, you're the one who's asked to give estimates. You're given a task and said, hey, how long do you think this is going to take to do? Here's what I recommend you do. And by the way, it's totally fair. You're an experienced programmer. You're a senior. It is absolutely fair to ask you to estimate things. The first thing I do is compare the task you've been asked to do to ones you've done before. If you've done ones like that before, then base your estimate on those previous tasks, because now you know how long it took you to do these things. If you haven't done tasks like this before, you're back to your manager and going, I've never done anything like this before. Why do you think it will take this long? Why don't we break it down? Why don't we break them down into hourly or daily tasks, and I'll start on it and I'll get back to you after the first day and tell you how things are going. There should be absolutely no reason they shouldn't accept that. Now, keep in mind that part of a manager's job is to push back on you and try to get the most accurate estimate possible. A lot of you get angry when managers do that, as if you don't understand. That's their job. They were trying to schedule a project. There isn't an infinite flow of money. There isn't an infinite number of people who can come into the project and rescue things that are getting behind. So things have to be estimated. That's just the world. So it's always possible to give estimates, but it isn't always possible to give an accurate one. But you have to try. And the reason for this is, unless you're an indie, the money's coming from somewhere. Those people want to know, and they have a right to know. They're funding this project. They're paying you. Saying you can't give an estimate and how dare they ask you is a little bit, I don't know. I wouldn't want to work with somebody like that. It's basically saying, hey, I know better than you about running a project, and my idea of running a project is just seat of the pants and we'll see what happens. That's not going to be a very good project. So the problem is, I want to talk too about the separate issues of what happens when you underestimate and what happens when you overestimate. So let's say you're given a task and you underestimate how long it will take. Basically, you're going to run out of time. There are three things that I've seen this lead to. One, you go to people, you have to go to your manager and go, look, I'm not going to have this feature done. So they may have to yank the feature out of the game. This is why, as a designer, I said I've often had design fallbacks as part of my design doc to try to account for this. But if it happens too much, the game is going to become significantly worse. You're going to ship a game where people who are playing the game, they don't know anything about the process. They're just going to go, I can't believe they don't have sorting in the inventory. I can't believe they don't have tagging inventory items for selling them. I can't believe they don't have junk items in their own category. If you ran out of time doing that inventory UI, that's why it's like that. Remember I said the answer to everything is money. Another thing that when you run out of time is you may have finished it, but you didn't have really a chance to look at it. Bugs. So basically the work for that task, which should have been done when you created it, would you just kick the can down the road, as one of my producers like to say, and now there's bugs. You turn it in and go, it's done, it's working, but you really have no idea how stable it is. Or if it's causes the frame rate to drop. Basically, QA is going to find bugs associated or that lead directly back to the code you just wrote. And then, of course, the third big bugaboo here is crunch. You underestimating a task is going to cause crunch later. If it's a feature that cannot be removed, even if it doesn't lead to bugs, but you need to finish it, you or someone else is going to have to do that work. This is going to cause crunch. Either the game is going to run over time or you're going to work overtime. Something is going to happen because of you underestimating how long it would take to do that. Now, so this leads to an interesting thing where a lot of people go, I'm going to be clever and I'm going to overestimate it. So if I think it's going to take a week, I'm going to say 4 weeks. I call this the Star Trek Scotty method, where he always used to tell Captain Kirk, you want that done in an hour? I can't do it. I can't do accents. And then he does it in 10 minutes. Well, this sounds clever, and you may be patting yourself on the back going, yeah, I'm always getting stuff done faster. But it leads to two things. One, if you give a big estimate for something, they may not even ask you to do it. They may just drop the feature. They may just go to a fallback because you said it would take too long. This has happened on my games where I asked for a feature as a designer. I got a really big estimate back. I thought it was wrong, But I'm like, I'm not going to push back on that because I've pushed back on it in the past and been told I'm a bad manager. So I just dropped the feature and went to one of my fallbacks. Game shipped. People were like, why didn't this feature exist? Then, later on, I've had a programmer go, oh, guys, we figured out we could have done that. Okay, too late. Feature got dropped. Players were disappointed. That's because you overestimated a task. But here's another thing that can happen. Let's say a task is assigned to you and you come back and go, yeah, you said it's going to take a week. It's really going to take me 4 weeks. There's a chance your manager will go, okay, don't do that. And they give you other tasks to do instead. And you think it's being dropped. Instead, the task is given to another developer. And let's say they do it in a week. And they're the same level as you. Like you're both juniors or you're both seniors. Well, guess what? You just got revealed as being someone who pads their estimates. And that is not a good look for you. You may think, well, I was just being cautious. Yeah, but you almost cost us a feature because you thought it was clever to quadruple all your time estimates. Both of these things, you being the reason features are dropped, or you being the reason, or you being discovered as someone who's padding their estimates that other people can do much faster than you, these are not good for you because they lead to a reputation that either you work on games that don't review well, or you're just a bad game developer. Trust me, you work on enough games, your reputation will build. And both of these things will come back to you. And I see a lot of people like, no, it wasn't my fault. It was something else. They didn't explain it to me right. That's fine if you're a junior. But if once you've gotten up to staff or senior level, that excuse holds a lot less water. And if there's other people who are doing better work than you, okay, maybe these things you say are true, but I have these other people who can do the work. So it's tough to under or overestimate. If you're padding your stuff, it's bad. If you're trying to just give really low ball estimates because you want to make your manager happy, it's bad. So what is the TLDW, which is probably too late because I'm already at 15 minutes. Here's what my recommendation for you. You've been asked to do a task. Try to understand what that task is. Ask questions. Compare it to tasks you've done before. Understand it as much as you can before you return with an estimate. When you do that, try to get big tasks broken down. If you have a month task, try to get it down to a daily. Sometimes you may even want to break it down to an hourly task, especially if it's something you've never done before. Try to get smaller tasks so you know early on, are you going off? Either are you doing it faster or slower? If you're doing it faster, hey, maybe that's great. Or maybe you misunderstood what it was. If you're doing it slower, that's not good. And again, maybe you misunderstood what it was. So try to get those tasks done in a much finer granularity. And then the last one, which should be obvious from everything I've just said, is communicate. Talk to your manager. Talk about delays. Or the rare, hey, I got ahead of things. I finished this in an hour and it was supposed to take all day. Maybe they can look at it and go, wow, you're awesome. Or maybe they look at it and go, this doesn't do half the stuff we talked about. Communication. It's tough. I get that a lot of people in the game industry are introverts. You're looking at one, but you have to learn to do it. Communication is two-way, so you can't just blame your manager for lack of communication. It's kind of on both of you. So, TLDW, understand the task, get it broken down as granular as possible, and then communicate with the person who gave you the task. That is the best advice I can give people on time estimation. So I hope Aegon Targaryen 1390, this answered your questions. Let the kids in. I don't remember what we did, but I don't care. May 27th, 1997, I wrote Good News and Bad News. The good news is, thanks to Mark Harrison's implementation of sound compression using Paul Edelstein's sound compression code, Fallout now fits on one CD. Yes, I was about to go to the people above me and go, we need 2 CDs, and that was expensive. So we got Fallout to fit on one CD. The bad news was we were having tons of problems with scripts. They weren't loading and saving correctly. They were losing variables. They were corrupting memory. It was a mess. So June 24th, 97, I started sending 3 new Fallout revisions to QA every week instead of just the one. I used to send them one a week because it took about 40 hours to play. Now I sent them one every Monday, Wednesday, Friday. I wanted to get a faster turnaround on the bugs. We also sent a revision for each of the three major platforms, Win95, Mac, and DOS. This is when QA started coming in on the weekend, even though some of them weren't paid. They just came in because they wanted to play. Awesome group. Windows 95, they reported as very stable, and they can get to the end game. The Mac was reported as very stable, but has memory fragmentation. It can be played to the end game, barely, but it reported a lot of memory issues. DOS was very unstable. It crashed, memory fragmentation occurred. The extra crashes in DOS we traced to sound code. Basically, someone in QA mentioned, hey, if I disable sound in the DOS version, all the crashes go away. So we searched through and looked for that. Here's where things get interesting, because people often ask me, well, when did you ship? September 30th, 1997, a build was sent to the duplicator, but that day QA found a bug. We fixed it, we retested it, October 1st, 1997. The final build was made, tested, and sent to the duplicator. October 7th, 1997. Reports were coming in from people on the internet saying they've actually seen the game for sale in US stores. But it wasn't until October 9th, because we started going to stores ourselves. October 9th, 1997, team members on Fallout confirmed finding the game for sale in local game stores. However, despite people telling me they saw it early and us actually seeing it early, October 10th, 1997 was the official release of Fallout. Now, we did patches, Fallout 2 started, but I've already talked for 23 minutes, 24 minutes, so I'm going to stop here. Anyway, I hope you all like that. I will link videos below. That is as close to as I can come from my notes to a pretty definitive Fallout timeline. I hope you liked it. Hi everyone, it's me, Tim. Today, let's walk through the Arcanum development timeline. A few weeks ago, actually it may even be a couple months ago, I did the Fallout development timeline. People really liked that. In fact, Stavros Nikolaou asked, can you do an Arcanum one as well? And I was like, yes. Interestingly, about doing this, this timeline was a lot harder for me to put together than the Fallout one. The Fallout one was basically looking at my notes and ordering them chronologically. This one was harder to put together because, interestingly, and I'll talk about this later in the video, there were no distinct roles on the Arcanum team. People did whatever they were good at. Because of that, we had no internal producer. Now, Leonard was the contact point with Sierra, and Sierra had their own producer. But for things, all the things that I did as the producer on Fallout, which was have schedules, project reports, meeting agendas, those things didn't happen inside of Troika. So when I was doing the Fallout development timeline, I just gathered together all the notes that I would write at home, usually on scraps of paper or whatever. And then the next day I would write my project report that I would send to the executive producer based on my notes from that week. Those things don't exist. So I had to go through a lot of Troika stuff. I have images of every Troika machine. I went through like 3 or 4 machines when I was there, and I have images of them, disk images. But it contains a lot of, stuff. But it let me dive into things like contracts to see dates and milestones and things like that. So I could put together a good idea of how we made Arcanum. There are less photos than you might expect because I didn't have a digital camera until 2003. So almost all the photos I'm going to show during this are things that other people took pictures with film cameras and either gave me a copy or scanned it and sent me a copy. So I do have a few photos to show. This video also has far more reference videos in the description than any video I've ever done. I think there's 15 of them in there. And that's because there's so much context that you will need to understand everything that I'm talking about in this video. So if there's anything if
if anything I say and you're not quite sure what I mean, see if there's a reference video below and watch that, because there could be an entire documentary done on the creation of Arcanum. To get started, I'm going to have to start at the end of my time at Interplay, and you'll see why in a bit. So, as I've talked about, I wasn't really happy at the end of my stay at Interplay. In October of '97, Fallout shipped. Fallout 2 had already been started by another team. Their output wasn't what management expected, so I was asked to step in and do my own. Watch the video on why I left Fallout 2. I explain all of this. But the cogent points I want to pull out, or the relevant points, are I talked with Fergus as early as November of '97 about thinking about quitting. And I think he was a little surprised. It's hard to say, but he said he wanted me to think about it. I talked to both him and Brian Fargo in December of '97, within a few weeks, again about me thinking about quitting, me not being happy. We had tons of talks about how we could restructure the team, how we could institute a royalty system. I mean, there was a ton of discussions. But if you watch that video, you find out there was a lot of other things going on and people, glomming onto Fallout. And I was just like, blah. So at the very beginning of January, when I got back from break, the winter break, I basically said, hey, I'm going to leave. Now I had a vacation plan for the very next month, and I was going out of the country, so there's no way to cancel it, anything like that. So I said, look, I can either leave now, or I can give you a 2-week notice, but keep in mind, I won't be here next week. Fergus asked me to stay to the end of January. I think, so the last day of January, the first day of February was my last day, and I said, sure, because what I did in those almost 3 weeks, after you subtract my week I was gone, I met with Chris Avallone, who's going to take over a lot of narrative design on Fallout 2, Zeb Cook, who was going to come on as a designer. I basically talked with everyone who was going to step in and do things that I would have either done myself or overseen to just get everything as smoothly transitioned as possible. So, February rolls around. I'm sitting at home. If you watch the video, Leonard and Jason submitted their resignation after they heard I did. We went around together and just tried to get hired locally. We talked to different companies. There were no takers at all, which I was surprised at. I'm not gonna not give you names because people seem to want to jump on people. So anyway, I do, in one of my rare dated notes from this time, February 5th, 1998, Jason got a call from someone at Blizzard, very high up in Blizzard, who basically was interested in hiring us. But he said, look, I'm getting told not to hire you. Basically warned. Yeah, bad things are going to happen to these guys. You don't want to be involved. I have no idea what it was. Again, I'm telling you something that Jason told me, that someone at Blizzard told him, that someone at Interplay told them. This is the biggest thing of telephone game ever. However, it was weird that we were having trouble getting any job offers. I mean, we just came off what was a really hot property. In fact, I've talked about in March of '98, I got a call personally from EA saying, hey, come up here and make Wasteland 2. And I was like, I just walked away from Fallout 2. Why would I move to go make Wasteland 2? So we finally just, we were talking for, February and all of March. And we're like, this is dumb. Let's just make our own company. So on April 1st, 1998, we incorporated Troika LLC. Yes, it was April Fool's Day, which is funny. It's not just the funny part. The irony of all this is we had never planned to make our own company, but after several companies warned us off, saying, oh, we were told not to hire you, that's the way we went. We were almost forced to do it. It's ironic in hindsight. I never saw myself running my own business. So in those last few months, I've been working really hard to write a new isometric engine, to write a new version of GNOL. Mine was called TIG, which is TIG isn't GNOL. Because as any programmer here will know, the first time you write something, that's never your best. And there were so many things that I wish were different about both those engines that I was working really hard about just writing engines. Right after we incorporated, I received a lawsuit threat from Interplay.
And they said they were considering suing me for collusion and economic tortious interference. I have to read that every time. The first one, the collusion, was because they said because Leonard and Jason quit after I did, I must have coerced them into doing it, or that we were working together. And anybody who knows us know we all did what we wanted. The second one was even more ridiculous because it claimed that I demanded to be on Fallout 2, which was the exact opposite. I was begging not to be on it. That I quit unexpectedly, which they knew months before I left that I was thinking about leaving. And that I did all those two things deliberately to set back development of Fallout 2, ignoring that I stayed for almost an entire month to try to get everything transferred correctly. So we talked to a lawyer. They sent a letter back basically saying, none of this is true. And we thought that was it. So I'll get back to that later. We then worked for months. We put together a 148-page design doc for a game that we were calling Epic. I don't know why I like that word so much. I always want to call my prototypes Epic. This is what would become Arcanum. We each worked from our homes. We would meet very frequently, a few times a week. Often we met at Jason's house because Jason lived close to Leonard. And I would just drive down there and we'd all meet. And we talk about design. We talk about tech stuff. I was excitedly telling about some new things I could do with the engine and with the TIG library because these were things we couldn't do before. But I said I'm rewriting it from scratch. There's all kinds of cool things where you can pick your color depth. You can do 8-bit games, 16-bit games, 32-bit games. You can do any resolution you want. You can ask the card what it can do and then say, give me your biggest resolution. A lot of really cool things. The memory management was really awesome. Anyway, during this, we weren't having any income. I had to remortgage my house just to get my mortgage payment down. And I'd only been there for 3 years, but anybody who's ever had a mortgage knows that the beginning of the mortgage is where it's mostly interest you're paying. So I restarted this 30-year mortgage, pretty much knowing I still owed the same amount of money, and I reset it to a full 30 years, but I got my monthly payment down. And this is the only way I was figuring out how to survive, because we weren't making any money. We had several publisher meetings during this time, and those weren't going very well either. In fact, one publisher, literally, the head guy started yelling at me in the middle of a meeting with about 8 or 9 people. He was telling me how stupid I was for still making things in C instead of C++. Before I couldn't even say anything, I was about to respond about, hey, I've done both, I know both, the C compiler does better optimization, C++ is slower, it hogs memory. Before I could say anything, Leonard starts yelling back at him. Leonard always has my back, but that probably didn't make that negotiation successful. But none of them had been. Even the ones that went well, nothing came of them. Fun times. So, sometime in July, we started talking with Sierra, Scott Lynch, a VP at Sierra. In August, they basically told us, in August of 98, that they were interested, but they wanted to see a working prototype in 90 days. Let me tell you what they wanted in that prototype. They wanted a sample level with combat against various creatures. They wanted spells. They wanted a structure that you could enter. And they said, yeah, either it's enterable when the roof flies off, or you instance into it. They wanted visual effects. They wanted a working UI. These were insane. We had very little code in place, just what I had already written since February. But at the same time, because I was writing that new engine and the new OS abstraction, and it was so much better, I felt like empowered. I was like, hey, this is gonna work. I've done this before. I got this. However, I had never written particle effects before, and I had decided for some reason that we needed real-time shadows. Yeah, we had a lighting model baked in the original Arcanum. So we ended up hiring Chris Jones, who was the other lead on Fallout. He would come work at my place every day. Leonard and Jason continued to work at their homes. We would continue to meet regularly, and we did it. We got them a prototype with all the things in it they wanted. And we ended up signing a full contract in October. I checked it. It targeted a ship date in April of 2000. So, spoiler warning, we didn't make that ship date. In late 98, in late October 98, we rented an office in Irvine and started hiring more people. In fact, we hired almost everybody that we were going to hire. The only people we hired later were some QA people. absolutely filthy, but we got a good deal on it. So we had it professionally cleaned. I mean, it was nasty. It was dirty. There were stains everywhere. There were stickers all over the bathroom. But the place had like 4 bathrooms and a shower. It was great. We did such a good job of cleaning it that the company renting it to us decided they wanted it for themselves and didn't renew our 1-year lease. By the way, side note, that place was haunted. It was weird. People told me, some people had stayed there late and told me they heard weird noises and it sounded like people were in the office. And I'm like, I stayed late one night. I heard some noises. I heard someone laugh. It sounded like a woman was laughing in the office next to me.
Okay, I think we got rid of the feedback. It's still there a little bit. It's definitely still there. Definitely quieter though. This is a feed